All right, today we're going to talk about triangle similarity. So we have talked about triangle congruence. It's kind of the same thing-ish, but good news is there's only three options. There's angle, angle, side, 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 and then there's side, angle, side. And today we're going to kind of ease into it a little bit, and you're just going to have to take a look at some pictures and identify whether the triangles are similar by angle, angle, side, 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 or side, angle, side. So how you know when you have angle, angle is when, if you are given two triangles, most of the time you'll be given actual angle measures here. Maybe you'll have some other situations going on, but how you know when you have angle, angle is when you have two angles in one triangle equal to angles in the other. So your angles have to be equal to each other. So like this angle and this angle are equal, and then this angle and this angle are equal to each other. So when you have two angles that are equal to each other, that is when you have angle, angle similarity. Today you're also going to have to write, not today, but you will have to write these like similarity statements where you match up the angles that correspond. You guys I'm not that worried about that with you guys. You're pretty good with that. The next type of similarity is side, side, side. So side, side, side is when, so side, side, side before you had like the dashes on the sides. Well, that doesn't work for similarity. So when you have similarity and you're looking at side, 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 that means that all three sides are proportional. So what you're going to have to do is you're going to have to do this right here. You're going to have to set up the fractions of the sides so that correspond with each other, like AB over DE, BC over EF, and like AC over DF. And then once you have those fractions, you're going to have to reduce your fractions. So if you're in class, you're going to use, I'm going to show you how you can use a calculator to reduce your fractions. If you're not in class and you have like a phone calculator, just make sure that you get the same decimal for every single one. I'm going to show that as well. So if all three sides end up being proportional, meaning once you get through and reduce your fractions, then you can say that your triangles are similar by side, side, side. The other one is side, angle, side. And what that means is that you have two sets of sides proportional, so you're still going to have to do those proportions, and remember we have to include that angle. The included angles are equal. So like here, BC and EF you would set up as a fraction, AB and DE you would set up as a fraction, and then they have these angles that are congruent to each other. And that would be side, angle, side similarity. So I don't have a ton of examples to I have a few to show you today. So make sure that you're taking notes along with me. Let's flip this page. So angle, angle is actually what I personally think. Angle, angle is going to be the easiest one to kind of see. So let me zoom here. We're going to take a look at 3, 4, and 6 here. So for number 3, we are given two triangles, and they want to know, are these similar by angle, angle? So to figure it out, you take a look, and we need two angles to be congruent or equal to each other. We have angle Y and angle C. They're both 90 right now. But then I have a 51 and a 39. Those are clearly not the same. But you do know, and if I were standing in front of you, I would ask, well, how can we possibly show that these are congruent using what we're given? And hopefully in unison you all would say, well, we can find the third angle because it's a triangle. You can find the third angle in these triangles. So remember that in a triangle, in the triangle all of the angles add up to 180. So if this is 39 and this is 90, we can add those together and we get 129, and then you subtract that from 180. And you do 180 minus 29, and you get 51 degrees. So this angle is 51. Well, that angle is 51 as well. So those two angles are equal to each other. So these two triangles are similar by angle, angle. That's it. You just have to show that the angles are equal. For number 4, we have 68 and 68, which is awesome. So there's one pair, you need to have 2. So this angle is 63, that's 54, but we can find that third angle, and if this third angle is 54, then we know that the triangles are similar. So we're going to do the same thing that we did on that other one, add the 68 and the 63 together, and we get 131, and take 180 minus 131, and we get 49. So this angle is 49. So we have 68s, which match up, and then this is 54. Well, neither one of these are 54, so these two triangles are not similar. It's that easy. Just use your triangles. And then number 6, there's no numbers involved, but we do have markings. So we know angle P and Z are the same. And then the other set of angles that I told you and I warned you at the beginning of the year that they're never going away are the vertical angles. So these vertical angles are also going to be equal to each other. So yes, two triangles are similar by angle, angle. So that's how you can prove angle, angle. And today you're going to have a worksheet with a bunch of different pictures on it, and you're going to have to figure out, is it angle, angle? Is it side, side, side? Or is it side, angle, side? And hopefully these examples kind of help you out a little bit. We will be doing this again next week as well once I'm back. For the next chunk, we are going to look at side, 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 and we're going to look at 9, 10, and we'll look at 12 as well. So in order for side, side, side to work, and this is the one where you're going to need a calculator, you have to show that all 3 sides that match up together are proportional, meaning that they reduce down to the same thing. So you're going to need to match up your sides, which we've done that already. You guys have been doing really well with that. So like on this triangle, and I always go from smallest to largest, I think that's just how I was taught. 5 is the shortest side. This is going to match up to the shortest side on this triangle, which is 4. So 5 over 4 is 1 fraction. Then I jump back over here. 12 is the next largest, and that's going to correspond to the next largest over here, which is 7. And then the largest side is 16, which matches up with 10. So these are my 3 fractions, and I need to check and see if they are all the same. So 5 divided by 4 is 1.25. So those who have to use a calculator, you get 1.25. And then 12 divided by 7 is 1.71. So already, because these two are not the same, no, these are not similar by side, side, side. That's all it takes, is just to show that. Let's take a look at number 10. Same idea. I'm going to check and see if my sides match. I'm going to match up my sides. So on this triangle, I'm going to use 5. That's the shortest. That's going to match up to the shortest side here, which is 18. Next largest is 12. 12 is going to match up to the next largest, which is 43.2. It's a weird number. And then we have 15, which is the longest. That's going to match up to the longest side there. So now I'm going to see what those numbers actually are. So take 5 divided by 18, and I get, I'm going to use a smaller one. So this is 0.27 repeating. 12 divided by 43.2. Same thing, 0.27 repeating. So far, so good. Check the third one, 15 divided by 54. Looky there. So are these triangles similar? Yes, they are, by side, 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 because we showed all 3 sides are proportional. Last one we're going to take a look at is number 12. Here we have 2 triangles. We have this triangle, and then, let me grab another pen. We have this triangle, like the big one there. The big, whoops, you can't see that, sorry. So we have the blue triangle and then the yellow triangle. So I'm going to set up my proportions and match up my sides. So on my blue triangle, I'm going to take the shortest side, which is 6, and that is going to match up with the shortest side on my yellow triangle. So I know this is 16, this is 20, because 8 plus 12, that's the length of that side. So of those 3, 16 is the shortest. Next largest is 8. That's going to match up with the next longest side, which is 20. And then 9 is the longest side in my blue triangle. That's going to match up with the longest side in my yellow triangle. So those are my fractions. Now we're going to reduce them or figure out what the decimals are. 6 divided by 16 is 0.375. 8 divided by 20 is 0.4. So yes, this would round technically to 0.4, but they're not equal to each other. So this would be a no. They have to be exactly the same. So I know that one only showed you one yes, but hopefully that kind of helps out a little bit. The next chunk is going to be looking to see if they are similar by side angle side. Side angle side means that you're going to have to do this for two sides only, and then they have to have an angle that's congruent. So I always look for the angle first, because if there's no angle that's congruent, then we really don't have to do any work. Here though, we do have the vertical angles going on, so there's our angle. So we do have the angle part. Now we have to check the sides. So of these two sides, 6 is the smallest. That's going to correspond to the smallest of these two, which is 24. And then I'm going to use 12 over 48. So I'm going to take 6 divided by 24, and I get 0.25. 12 divided by 48 is again 0.25. So I have two sides and the angle. So yes, these are similar by side angle side similarity. Number 14 here, last one that we're going to take a look at. So here again, I have the angle. I always look for the angle first, and I think that's just how I was taught. So there's the angle. Now I have to check the sides. So looking off of this one, between the 40 and the 44, 40 is the smallest. That's going to correspond to the 25. And then I do 44 over 27.5. So I divide these out. 40 divided by 25 is 1.6. 44 divided by 27.5 is 1.6. But, which is great, but look here. Here are my two sides. Here are my two sides. Is that angle in between? No. So that is where this one does. You have to be careful. It has to be two sides, angle in between, two sides, angle in between. So even though these two sides do end up being the same when you reduce them, because it's not the two sides that kind of surround this angle, that's why it's not side, angle, side. Remember when we did these before, you had side, angle, side. That's what you're looking for again. Two sides, angle in between. So that's why this one is a no, because this actually would be side, side, angle, which I'm sure you're all giggling at now. So today you have an assignment, a little riddle to fill in to help you make sure you understand these different side, 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 angle, side, and angle, angle. And if there's any questions, we definitely will be talking about this in the upcoming week.